In this video, we'll be working with a variety of percentages. We're going to look at some fundamental relationships that we have with percentages rather than try to talk about a set of formulas that we might have, because it's really just all about either multiplication or division. So we'll leave out talking about a type of formula and stick to the fundamental operations of multiplication and division that are at work when we use percentages. First, we want to have a handle on how opposite operations work when it comes to multiplication and division. So if we have one multiplication, like 3 times 7 equals 21, then there can be a division in reverse. 21 divided by 7 equals 3. So multiplication one way, division the other way, but really these two are sort of the same thing at heart of what's going on. One is showing the multiplication relationship to make 21. The other is showing that if we have a multiplication relationship, automatically we also have a division that's going in reverse. Starting with that answer 21, divide by 7 gets us back to 3. So when it comes to instances where we know there's a multiplication relationship, but we don't know one of those numbers in the multiplication, we know that it's going to be an option to do the reverse division. 57 divided by 3 will give us the answer. We don't need to have multiplication tables memorized. We really want to understand that a multiplication with an unknown, if we divide in the opposite direction, we can get to that unknown. And if you play darts, you might know that 19 times 3 is 57. So the way that we want to see the multiplication and the division in working with percentages would be the following ways. The way that we would use multiplication with percents would be to multiply a percent by a reference value to equal some final amount. The percent, when we do the multiplication, we should be sure that we have it in a decimal form. And the reference value would be thought of as like our starting amount, our full amount, full price, something like that. Our original amount, original value, what we take the percent of by multiplying is the reference value. And the result of this multiplication will give us some kind of final amount. So let's hit a few examples where we look at this multiplication relationship that we have. Percent times the reference value will equal some final amount. So how about this example? What is the total cost of a $400 computer with 8% tax? So we have a situation here where we have the percent, we have the reference value, the amount that we want to take 8% of, and we know that we do that with a multiplication. The 8% will need to write that as a decimal, 0.08, and it's going to give us our final amount. How much is 8%? It's $32, and then we can add that into the $400 to get our total, $432. Now we want to be able to address these percent problems, if possible, with just one multiplication. And if you noticed, we actually did two operations. Our multiplication only told us the 8%, and then we had to do another addition to get the total. So there is a way for us to accomplish this problem with just one multiplication. To do this, we have to take our understanding of percents just a little bit deeper. When we calculated this total of $432, we were taking the $400 from the computer plus the $32 from tax. The $32 was 8% of the price, and the $400 is the whole price, 100%. So when we're totaling this up, we can actually see that what we're finding is the total of 100% and 8% to say we're really looking for what is 108%. That's going to give us our full amount and an extra 8% built in. So if we go back to this multiplication and just do $400 and say this time we're trying to find what is 108%, we still want to change it into a decimal for this multiplication. So 108% would be 1.08, and the multiplication will give us exactly $432. So going forward, we're going to be paying attention to what percent could we use to make these calculations as efficient as possible. But we're not trying to think about doing shortcuts or what's the fastest way, the best way. Still, we want to try to find ways that make sense to us. but we will find problems that are a lot more manageable if we can embrace this idea about percents. So when we see we're looking for a total cost of the computer and tax, we should be able to say, well, that is 100% for the full price plus 8% more for the tax to give us this total 108%. And using that percent in the multiplication gets us right to our final answer of computer and tax combined. Here's our next example. If you have $30 to eat out and you want to leave an 18% tip, how much can you spend on food? So we want to focus on what percent should we be using, what is our reference value, and what is the final amount. Now here's another example where we are looking to increase an amount with a percent. We're talking about a food bill and then increasing that amount by 18%. So again, we want to see that we're looking at 100% for the food and 18% more for the tip. We're going to ignore tax in this problem. So because this is a scenario where we're looking at increasing our amount because it's extra 18%, we're looking at using 118%, or as a decimal, 1.18. So we've got the percent. Now we want to figure out, do we know the reference value? We're taking 18% of what? Well, if you know how food and restaurants and tips work, you want to take 18% of your food total. And we actually don't have that amount right now. We don't want to take 18% of 30. That's the total cash that we have. We know that the 18% is 18% of our food total. We just don't know what that is yet. So 118% of the food total, which we don't know, so let's just call it F. The $30 is actually the final amount, what we want to be left with when we have the food plus the 18% for tip. It should equal $30. Now, either you're thinking about solving equations, how do we figure out what is F? We would do the opposite of times 1.18 and do a divide by 1.18. Or if you thought back to our first couple of examples of the 3 times 7 equals 21, so 21 divided by 7 equals 3, it's the same idea going on here also. We don't know what F is in the multiplication, so we can do the opposite, divide 30 divided by 1.18. And we get a result that is about $25.42. Now I can tell you that if you've thought about using 18% of the $30, you're just going to be off path because the $30 is not our reference value. It's not what we take a percent of. When you look at your bill at the restaurant, you look at how much you spent on food and calculate 18% of that. So even though we don't know how much is spent on food, we still have to say we're calculating a percent of the food. So in this case, we can use a variable as a way to see that it's a division necessary this time to figure out what is this reference value, the total cost of food. Remember, you can always check these problems. So if you said $25.42 is spent on food, and you calculate 18% of that and add it back in, you're going to get yourself right almost at 30. It's because we did a little bit of rounding right here. But if you found an 18% of $30, you have just gone off path. You're not going to get an answer that should be about $25.42. Here's our last example for this first batch of questions, and it's actually going to give us a nice transition into the next batch of questions. So here, if you spent $75 total at the restaurant, and the food total was just $63, what percent tip did you just leave? Well, let's see. First, the percent, we really just don't know that at all. That's actually what we're trying to find, what percent. Do we know the reference value, our starting amount, or what we take the percent of? And it's going to be the food total that we take the percent of. So 63 is our reference value. That gets multiplied by the percent, and this time it's the percent that's unknown. So I'm going to use the variable p. And I know that the result of this calculation is the $75 total spent at the restaurant. So we're looking at another instance where we need to divide. We have a multiplication with an unknown. To find that unknown, we'll do a divide. 75 divided by 63. As a result, I get approximately 1.19. Now remember, in this relationship of reference value times percent, that percent is always as a decimal. So when we see our answer is still as a decimal. Thinking of it as a percent, it would be 119%. So does that mean we left this enormous tip? No, because the 75 was the total. It was the total of food and the tip. The food part was the 100%, and the tip would only need to be 19%, and that's going to give us our total 119%. So we still are embracing this idea about what percent actually are we using, and in this scenario, a 19% tip is what makes us work with 119% for our total $75. Now the future percent problems that we do, we will be able to relate them all back to one of these three examples for the most part, but we might not always set it up the same way every single time. What I want you to see in this problem is that we could have thought of it in a little bit of a different way. If we wanted to just talk about comparing numbers with a fraction, we could say, well, compare the $75 total to the 63 that you began with from just the food total. So now I'm thinking, well, I'm just comparing these numbers with a fraction, but look at what operation we would do. The exact same that we see right here, 75 divided by 63. So whether we think about the multiplication or division relationship with percents, or we think about we're comparing numbers, a final amount compared to an original amount, that would give us the same answer, about 1.19. So we're talking about a 19% increase.